This video is the start of probability, and the first thing we're going to look at is concepts within probability. A few key terms that we'll just discuss in this first section. If you roll a standard fair die, which is a single word for a dice, there are 6 possible equally likely outcomes. A particular combination of these outcomes, such as rolling an even number on the die, a combination of outcomes is known as an event. The probability of an event A happening is denoted by P and then in brackets A. This will always be a number between 0 and 1 inclusive, which measures how likely the event is. So a probability of 0 means it is definitely not going to happen, it's not possible. A probability of 1 means it will definitely happen, there is no option for it not to happen. If the die was to be rolled multiple times, each repetition of the process is known as a trial. One way of estimating the probability of an event is to use a relative frequency, which is also known as experimental probability. So our first example, a random sample of 80 collectible card packets was opened. 23 were found to contain a special rare card. Another card packet was purchased, estimate the probability that it contains a special rare card. So from the information we have already been given, we know that 23 out of 80 were found to have a special rare card, which basically means the probability of a rare card would equal 23 out of 80. And that's it. We get this probability by basing it on something that has already happened, which is our experimental probability. It's based on an experiment of something that's already occurred. Now we also have a theoretical approach. If you know all the outcomes are equally likely, then you can work out probabilities theoretically. The set of all possible outcomes, we call it the sample space. So for example, the sample space of rolling a standard die is 1, 2, 3, 4, 5, 6, because they're all the options that are on a standard die. Now we can use the notation n and in brackets A, which means the number of outcomes in the event A. And if all outcomes are equally likely, then the probability of A is equal to the number of outcomes in A divided by the number in the sample space. A quick example, a fair standard 6-sided die is rolled. Find the probability that the outcome is a prime number. What we first of all need to think about is how many prime numbers are there on a standard 6-sided die. So our prime numbers would be 2, 3 and 5. Therefore, the probability of getting a prime number would be equal to 3 out of 6 because we've got 3 prime numbers out of the possible 6 numbers we could roll. And then we can simplify that down to a half. Next, we're going to look at complementary events. So the complement of the event A, which we write as A dash, occurs when the event A does not happen. Since an event either happens or doesn't, the sum of an event and its complement must be 1, which leads us to the formula that the complement of A, so the probability of A dash, equals 1 minus the probability of A. Example 3, the probability of no buses arriving in a 10-minute interval is 0.4. Find the probability of at least one bus arriving in that 10-minute interval. Now we know the probability of no buses arriving is 0.4, so our probability of a bus arriving would be equal to 1 minus 0.4, because the 0.4 is a bus not arriving, which means a bus arriving would be 0.6. Now remember, with probabilities, you can write your answers as decimals or fractions. Doesn't matter, the main thing to note is you cannot have a decimal within a fraction itself. So you couldn't have 0.2 divided by 0.4. You would need to have that simplified to either a decimal or a fraction. The last thing for this video is the expected number of occurrences. So if we know the probability of an event happening, then we can use it to estimate how many of the total number of trials will result in that outcome. Now our formula for this is that expected, which is often used with a capital E, equals a probability of A, the event happening, multiplied by N, which is the number of trials. Now one thing to note here is the expected number does not need to be a whole number, it is totally fine for it to be a decimal. Example 4, an archer has a probability of 0.3 of hitting the bullseye. If he takes 12 shots in a competition, find the expected number of bullseyes. So we know the probability of hitting a bullseye is 0.3. So our probability, and say we had our event of hitting a bullseye was A, that equals 0.3. So our expected number would be our probability, which is 0.3, how many shots are we going to take? We're going to take 12, so 0.3 times 12, which means we would be expecting to hit 3.6 bullseyes. We know a decimal of a bullseye is not possible, but as I said in that note before, an expected number can be decimal. It doesn't need to be rounded to the nearest whole number. And that is the end of this video.